So here's a demonstration on some of the problems that you were not assigned on worksheet number 5 for the first standard. And in problem number 3, because you were assigned number 1 and 2 to describe whether they were a stretch or a dilation according to what was given to you. On number 3, they're telling you the center of dilation is G, and they give you the points of G and A. And they ask you to determine the slope of the line GA from G to A. So it's important when they say from a specific point to another one that you do this in a particular order. Normally when we're finding slope between 2 points, it doesn't matter which point we pick to be our first one and which one we pick to be our second one. But when we are using slopes in our rules, it does matter this way. So if we're going from G to A, we're going to let A be the second point. And they show you that right here, that this is the second point and this is the first point. So when we do this and we move this over here, they're telling you that this is the slope formula, and you should also have this memorized already, that you just take one of the y's and subtract the other y value, and then on the bottom of the fraction or ratio, it's the same x that you started with minus the other x. So if we're using those coordinates, we have 3 minus 1 over 5 minus 2. That gives us 2/3. Okay, so from there, they want you to, in question B, they're saying, okay, using this graph in number 2, how can this slope help you find A prime if the scale factor is 2? And so what I am saying to do here is multiply the slope by the scale factor. So if we have a slope up here of 2/3 and our scale factor is 2, then we're multiplying the top of our ratio by 2 and the bottom of our ratio times 2. And so we get 4/6. That's our rise over our run. And so we're going to do this from point G. Let me try to delete that out of there. Okay. And just so you know, if you were using vector notation, the rise is the y direction, the change in vertical direction. So that would be the change over here for the y. And the run is our change in horizontal distance or x distance. So it would be over here, just flipping it around the other way. So this is vector notation. And so if we come over here and delete that, you can see what happens. If we're going from G, and our original slope was 2/3, and in worksheet 4 you saw me do this. I went up 2, right 3, up 2, right 3. I just did it twice. Well, if you were going to use these rules of coordinates and things like that, and to tell how it would go from G all the way to A prime in one shot instead of, doing this twice, you would just multiply your slope by the scale factor, and this is how it would work. So yes, up 4 and right 6 would get us to A prime. And so in using graph 3, how can this slope help you find A prime if the scale factor is 1/2? So what would be different? Remember what we did before in the last worksheet? Instead of going up 2, right 4, we'd go up 1, right 2. Well, that's the same thing as if we took this and just multiplied it by 1/2. So if we took our slope right here and cut each one of those parts of the ratio in half, we'd have 1/3/2. I know this looks really funny, but it's true. It's 1/3/2. The vector translation would look like this. This is 1.5, isn't it? So the horizontal change would be 1.5, and the other one would be 1. Oops, sorry about that. Let me go back and fix that. Okay, there's our correct graph there. So that's graph 3 showing you up 1 over 1.5. Did I say 2 a minute ago? This was up 2, right 3, so you'd go up 1, 1.5, not over 2. If I had said that, that was a mistake. Yes, up 1 over 1.5, because that's half of 3. Okay, got that so far? Let me just scroll down. You can see that. That was the vector notation we had a minute ago. Okay, so that's problem number 3. If we go over to problem 4, this is using rules without a graph. So we have no graphs here. And this is like what I was talking about in that last page of that pink packet of notes. So this is pertaining to that. You have homework problems 4A and B. I'm going to show you C and D. I don't know why I have that scratched out. But once I show you this, you should have no problems doing A and B on your own and the other ones. So again, they're telling you to find the slope of the line GA or ray GA, or segment, sorry, that's a segment GA My eyes are going bad. GA from G all the way over to A. So if we let A be the second point, we again would go this y minus this y over this x minus this x. And so if we take that away, let me just move it off to the side. There we go. We get -5 minus -1 over -4 plus 3. That gives us -6 over -1. I almost started to reduce this myself and call it +6. Don't do that. Leave these alone when you're using these kind of rules without a graph, okay? Because to determine A prime, you want to leave this and use this in your rule here. So what's going on here? They gave you a blank spot here and then +2 times a blank spot. That was a comma. And then they have a blank spot +2 times something here. They're telling you these are the coordinates for what's going to give you A prime. So this was the G's x coordinate. See this G over here? Its coordinates were -3, 1. So the x coordinate was -3 and the y coordinate was 1. To this x coordinate, you are adding the scale factor times what the run was. Here was the run. Here was the change in x direction for the slope. And over here, what you're adding to the y coordinate was the scale factor times the rise part, the change in y. Okay, so this times the scale factor added to our original y coordinate, and over here our original x coordinate, add the scale factor times the horizontal change in the slope. And if you clean that up, you're adding -3 plus -2, there's your -5. And here we have a -12 plus 1, there's your -11. So you would have gotten this had you had used a graph and just kept using the slope. What was this? A slope of scale factor of 2. So this is just, you know, it's not a visual approach. It's just using your coordinate rules and things like that with slope to figure out what it would be. And so in example D, again, our center of dilation, they're calling point G. Here's our point A. The scale factor is 1/3, so we should expect this to be smaller than, or you know, it's a contraction, right? It's a reduction, not a enlargement. So our scale factor is 1/3. Once again, we're going to find our slope right here, and it's 13 minus -5 over 1 minus -2. Those change to positive right there, plus. And so we have 13 over 8. Leave it alone again. Don't call it 6. And so to determine A prime, move away, come off of there. There we go. So again, our original coordinates for G, because we always go from the point that's the center of dilation, right? We're always moving from that point each time. So that's why we're going back to this one. So -2 was the x coordinate, -5 was the y coordinate. We're multiplying the scale factor times the portion of the slope ratio that we need. So with the x's, it's the run. With the y's, it's the rise. Okay, so that ends up being 1/3 of 3 is 1, and -2 plus 1 is -1, and 1/3 of 18 is 6, and 6 and -5 is +1. So going from G to A prime, if the scale factor was 1/3, you would go all the way over to, actually it would be at -1, 1, which would be between G and A, because it is a reduction. Okay, you getting this so far? I hope. And then our last one here, for example, E, the scale factor is now 5. So when you get the slope from G to A, then you're going to multiply the rise over run by 5, and you're going to add the appropriate parts of that to the original coordinates of G. So let's see. You work on that. Let's see what you get for your slope. What's 7 minus 3 over 4 minus 2? Ah, why do these things never want to move for me? There we go. Did you get 4 over 2 and leave it alone? And then take this, multiply that by 5. Take this, multiply that by 5. Add those to the correct parts of G, the correct coordinates that you had before. And you should get this. So A prime would end up over at 1223. Okay, you're asked to answer question number 5 on your own, but I'm giving you a hint right here. because I said this at the beginning, when you're going from one point to another, the direction matters. Because we're dealing with dilations here, and sometimes we have positive dilations, right? And sometimes they're negative, and sometimes they're fractions if they are reductions, and sometimes they are, bigger than 1 if they are an enlargement. So knowing that the direction matters, you are to figure out if this student's work is correct or not. Or actually, they're saying what is wrong. So they're telling you something's wrong here. This is not correct. A prime is not the correct coordinates. So let's see what you do on your own to figure that out, and I will see you in class.